So welcome, and today we're going to talk about loops and variables. I think it's a fairly short lecture, and then after that, I'll go and we'll look at our what are the flow charts that we did. Actually, in this lesson, there's a bit of flow charts in there as well, so you can sort of see that as we go. Hopefully, that'll make some sense to you. Now, you might remember that in the previous lesson, we said that there was something like 2 different types of branching. I'm not sure if I used the word branching. I think the word that was used was selection. Actually, I think I did use the word branching, but in the notes, it's used the word selection. So looping is like a special case of selection. But in looping, what we're doing is we're repeating a segment of the code over until some condition is met. We don't usually, if that condition is never met, then we'd have this problem, which we'd call an infinite loop. Infinite loop problem, the program would never end. It just keep repeating. So we don't like that. So we have some way of controlling the loop so that we can stop, but we want to stop when we're ready to stop. And that's what we'll talk about today. We got a couple of different ways of doing that. So as it says here, we want to do repetition. Remember, repetition is one of the 3 major constructs of a computing language or algorithm. Those 3 constructs were, we could have sequence, that is where the code is processed 1 line at a time, first line first, second line next, third line next, like that. That's what we mean by sequence. We had selection, which meant that we could do branching, where we would say, okay, well, when we get to this particular point, if this condition's true, we'll do that. Otherwise, we'll do that. Or otherwise, if that condition, then we'll do that. So we actually looked at that with the particular programming construct called the if statement, if then else, and Boolean algebra. We talked about that for selection. And so the third, which is quite closely related to selection, and selection was really the topic of our last lesson. The third is about looping. And the idea of looping is a certain amount of code will be repeated until a certain condition is met. And so we've actually seen this. Now, the reason why I've got this in PowerPoint is so that we don't miss out on these notes at the bottom there. So this is the point about this. What you're going to see here is there is no evidence of a selection. There's no diamond symbol there. And all we've got is we've got an input and we've got some arrow around that. So this is an error. This is not the way it's supposed to be. We would need to modify this flow chart to make it something that would work. So what would we do there? Can anybody suggest what we would do to fix this flow chart? I think we might have actually looked at this before, have we not? What would you do to fix this flow chart? Well, if you can't see it, you would put a diamond here. There would have to be a decision at this point here to decide whether we go back up and do this again. We don't want to keep doing this output all the time. We would want to have some control over that. So we could put a decision box right here where my cursor is. And depending on what that condition was true or not, we would go back and repeat that output or not. All right, so as this slide indicates to us or tells us, there's 2 different ways of controlling that loop. Now, I showed you there in that diagram we just looked at that we'd want to have some kind of decision, a condition. And we've seen conditions in an if statement. We could use a different kind of statement, which works sort of similarly, while, but there would still have to be a condition. Now, what this slide is telling us is there's 2 different ways we can handle that condition. One is we can just count. That's if we know how many times we're going to do the loop before we start. If before we start, we know I'm going to do this loop 100 times, then we would probably use a counted loop. Now, there is an analogous or similar way of doing this with a for, but I'm not going to teach you that in this course. That's for a later course. A for is just a neater, shorter way of doing a while loop. And so neater or shorter sounds like less typing. So probably you'll get interested in doing a for loop later. But at the moment, we're just going to concentrate on while loops. But a while loop is going to have a condition in it. And that condition could be a number. All right. While this variable, whichever we've set, is less than this number or bigger than this number, can be related to some other number, then we're going to continue doing it. So what we typically do is we start out with a count of 0, and then we add 1 to the count inside the loop. And then when the count gets to a certain amount, then the condition will stop the loop from running. That's called a counted loop. Now, the other type of loop is a sentinel loop. And with a sentinel loop, what we do is we just say some special condition becomes true or false. And when that special condition comes true, then we stop. And so that we would use the sentinel loop when we don't know how many times we're going to do the loop ahead of time. We don't know. So we're going to have some special signal to tell us when, as opposed to the counted loop where we know ahead of time how many times we're going to do it. And so, yeah, a counted loop, we know that we need to write out for our punisher, whoever that punisher is, 100 times that we wouldn't do the thing that we're not supposed to do or something like that. That could be a counted loop. We know ahead of time. Now, this is the flow chart that I showed you a minute ago, but here it has been fixed. It's been improved. The error has been removed. We now have our condition, which is in the selection statement there at the bottom, which is the number of, I can't read that because it's on yellow, iterations. Iterations means repeats. The number of iterations is less than 10. So if sorry, is bigger than 10, or it actually says equal to 10, that's fine. So when the number of iterations becomes equal to 10, then this becomes true and we end. But as long as it's not equal to 10, we keep going. Now we're actually missing, this still has an error in it because it hasn't initialized the well, it just used iterations. So yeah, I guess it's all right. So this is how we improve that error, is we start out with a count. Here we use the word iterations, but yeah, that's fine. And then inside the loop, we add to the count. And then eventually our count will become true and we'll stop doing the punishment. So we should draw a flow chart that asks the user to enter their age and then displays happy birthday. I think we've done this as a program, but I'm just going to do it on the board behind me and you guys are going to help me, right? So the program's going to ask the user for their age and it's going to display happy birthday however many times their age is. We always start a flow chart with a start symbol. All right. And then straight up, it tells us what the first step is, which is to ask them their age. So we could get the age as an input. So I'm going to show that as an input. I suppose maybe I could say input age or get age. I'll just say get age. Get age. So that's our input is coming into our program. And then what we're going to do is we're going to print happy birthday. Well, we better have a counter, right? So let's say our count is equal to 0, or you could do 1. Now notice that these symbols are different, that this symbol here has got the parallelogram, but not rectangle edges. They're not 90 degrees, whereas this one has got the 90 degrees because this is a process. What we're doing here is we're initializing a variable. Initialize means to set it to its starting value. So we're saying that we've got a variable called count and its starting value is 0. And then what we're going to do is we're going to print happy birthday. That's also, oh, well, that's an output, isn't it? So let's do that like that. And then what we would do, it was increment the count. Increment means to add to in a small amount. Now we would have our condition. I hope you can see this without the screen being in the way. I'm sorry if you can't. Can you? You see this? All right. So now we would have our condition, which would be the count is less than the age. As long as the count is less than the age, then so that's a condition. Sorry, that's a bad looking diamond, but it is a diamond. So this is saying that the count is equal to the age. If the count is equal to the age, then we go back and we print again. If it's not, then we're going to, yes, finish. So that's how I would do that. And I hope that you guys would think of doing something like that as well. We'll have a look at this. I think we've done this in Python, have we not? So I'll leave the flow chart on the board, and maybe we'll revisit this in Python later. Now the Sentinel loop. Now, again, I've said this once before, but I'm saying it more than once because it's important. So I hope you remember this. The difference between a counted loop and a Sentinel loop. In the counted loop, we set a counter. Inside the loop, we add to the counter or subtract from the counter, depending on which way we want to do it. But the thing is that the thing that controls the loop is the count. We use a counted loop when we know how many times we're going to do the loop before we start. Before we start, we know how many times. With a Sentinel loop, we are going to end the loop when some special condition occurs to us or sort of arrives. We often just give the control to the user. The user gets to say, well, you know what? I don't want to enter anything. And so we give them a special code that they can use to stop the loop. All right. So for example, typically we'll say something like enter a negative value to stop. All right. Or enter the word no to stop or something like that. So the user will be given the opportunity to end the loop. That's because we don't know how many, maybe, you know, we're asking people, this is a thing we're going to gather data about a husband and a wife. We're asking them about their children, right? So please give us the name of your first child. Give us the age, all right? You know, and okay, please give us the name of your second child. Well, you know, how many children do they have? Maybe somebody's got no children, right? So we would say, if you don't have any children, or if you've given us the information about all your children, say N to finish, right? And so some people would not put any information because they got no children. Some people might have 8 children. Some people might have 2 children. You get the idea? So we don't know when it's going to finish. We're putting the control in the user's hands. So we would use a Sentinel loop. So here's an example of how that might be. So this one here, we're getting information about a selling things, and it's asked. So we're getting some input. What is the sales amount? We calculate the total sales, and then we output the total sales. Well, maybe we add one sale, we add another sale, we add another sale. Eventually, we're going to end up with no more sales, right? One day we might sell 200 things. One day we might sell 10 things. One day we might not sell any things. And so we're going to have them put in a special value for a sale to sort of allow us to end the loop. So typically we'd say something like, okay, if the sale value is equal to 0, then that means we don't have any more sales. And so that would be the end of the loop. Now, it might look a little bit clumsy and it's a little bit contrived. What I mean by contrived is it's not exactly sort of facing reality. You know, we're going to have a sale of 0 and that's how we're going to know when we finish. We're kind of making it up, but we're making it up because we have to have a way of stopping the loop. And so what we're doing here is we're just the easiest one we can. We know that nobody's going to have a sale of 0. So if we say sale of 0, that means we finished. And so that's what we're doing there, you know. So add a sales amount of 0. When we do, boom, we're done. And so that's how we get out of the loop. So that's what we mean by this statement here. The Sentinel value should be out of the range of the normal inputs. And so we'll typically say things like enter a negative value to stop, or enter 0 to stop, or enter something that we wouldn't normally enter. And that way we can control the loop. It won't just stop sort of randomly without us actually being in control of it. And so, for example, you might say, use a negative number if we had a negative 10. But the thing is, if we're going to do that, we have to make sure that we don't add that number to the total. I guess with 0, we could do that, right? If you use a negative number and say the sale is minus 10, we'd have to make sure that our adding to the total is not going to be influenced by the Sentinel value. Well, one way to do that would be to make sure that we test the Sentinel only after we've done everything else in the loop. So nothing else in the loop is affected by the Sentinel. Yeah. Now, what's this ask us to do now? Draw a flow chart of the program that outputs "I will not cheat" on assessments, and ask the user if they want to print it out again or stop. If the user says again, it will loop, otherwise it will exit. So this is an example of a Sentinel loop. The user is in control. you would do something like this. Of course, you need to stop, start. And we don't have any input just yet. Well, we could. We're gonna let, so we have to decide, are we going to let them, start out printing, I will not cheat, or is it possible that we can have them not print at all? So that the number of times that they're gonna say, I will not cheat is 0. So what's the word that we're gonna use? Again, I will not cheat. Print it again or stop. So they're going to use again, or else they're going to use stop. Well, let's just print it. So we're going to print, I will not cheat. When we do then the thing is, then we're going to ask them if they want to print again. So we get an input, that's an output. So the input is, oh, well, no, we're going to get prompt to continue. Or and or whatever it is. So we're going to ask them to enter one of those things. So that's an input. This is an output, that's an input. And then depending on whether it's a again, if it says again, then this is true, and we go back up here. Otherwise, we end. So it's pretty similar to the other one, I think. We could tweak it a little bit by asking this up here. But yeah, this will work. Now notice that the very last thing we do inside the loop before we go to the selection, the very last thing is we get the prompt. That way, this doesn't affect that. Also with the counted loop, the last thing we did here was change the count before we did the selection. So these other things are not affected by the count. So as it says, I've already said this a couple of times in this lecture, so it must be important. It keeps on showing up. When do we use a counted loop? When do we use a sentinel loop? So you know it now, right? We use a counted loop when we know how many times we're going to do the loop before we start. We use a sentinel loop when we don't know, and we're going to give the user control when they're going to do the loop. When they're going to stop the loop. And so we give them a special code that they can use. All right, so that's kind of the end of that little subtopic. So we got another subtopic here, the idea of memory. And specifically, when we're talking about memory in this lecture, we're talking about memory and variables and constants. So you might remember that memory in your computer is really going to be stored in bits. Bits are zeros and ones. And so you have memory address, and the only stuff that's in there is zeros and ones. And so our operating system and our computer program has to talk with us. We don't really work with zeros and ones very well. So we have a way of sort of referencing things with words and stuff like that. And so we create variables with names that we understand. And then the operating system and the programming language is nearer to us. But the programming language and the operating system then take those names that we've got, convert them to zeros and ones, and then put that in a memory location, which they have an index for. So they know, so that the operating system is able to retrieve from that memory position the value that we put in there with a name of a variable. So that's the memory, and yeah. We've got two different types of things that we can store that way. I've used the term variable, and there's another thing called a constant. Hopefully the two words mean something to you. So a variable could change, probably will change the value that's stored in it during the processing of the program. Now remember, when I say the processing of the program, these values are stored in the random access memory. The random access memory is only available as long as the computer program is running. right? The random access memory will be flushed out when the computer program ends. So during the running of that program, some space will be set aside in the memory. That space will be indexed and given a variable name, and the variable can change its value during the program. Now, a constant is like a variable, except that we set the value of the constant at the start of the program and we don't change it until the end. All right, so the only difference between a variable and a constant, they have names that are sort of similar. We use the memory in the same way, but with a constant, from the start of the program to the end of the program, we don't change its value. So the constants are going to be used for things that would be constant. So for example, a tax rate may or may not be a variable, but typically you might set that as a constant for the start of the program. You wouldn't expect the tax rate to change during the process of the program. A variable another constant would be mathematical constants, right? Like the value for pi. You could put the value for pi in there. You know, that's never going to change, right? Not just during this program, but ever. But other things might change, like, you know, how many hours did somebody work during the week, right? That's not going to be a constant, right? I mean, different if you're doing some kind of calculation like that. So yeah, there's some example of a constant, the constant pi, which I mentioned, which is a mathematical constant. It's been worked out to a lot more decimal places than that, but actually most programming environments like the IDLE, which I've shown you a couple of times. I haven't asked you to program in it, but you will be later. Python, there's libraries that have pretty precise value for pi. And so we just include a math library and that value is there. We can just say pi and math pi, and it will give us a very precise value for pi, which we can then use in our calculations. But we would set it as a constant. The point that you're supposed to get out of this is during the program, we will not change that value. On the other hand, we might be calculating the circumference. Would you do the circumference? Yeah, the circumference or the area of a circle, knowing from its radius, and the calculation is based on pi and the radius. So we might be doing that for many different circles. And so because we're doing it for many different circles, we would enter the radius value as a variable because we would change it from circle to circle. It's going to be different. But the pi value would never change. That's why I mentioned it for a tax. You know, if you had a program which calculated somebody's taxable income and then calculated the amount of tax that they had to pay, I suppose in that program you might set the tax values as constants. Now, if you guys don't have much in tax, there is tax. So when you import something into Qatar, there's a tax. You have to pay, I don't know, 5 or 10% depending on the thing. So those values could be set as a constant. Somebody's computer program, you know, we bring in the container of goods. Somebody inspects it. There's a cost for that, and then there's a tax applied based on the value of the goods. And so that 5% or 10% or whatever it is, that could be set as a constant because everybody's going to be charged that on top of some other inspection values and things like that. So there's something here which is these are not going to stop your program from working if you don't do this, but it's good practice. So the good practice that we're referring to here is how do we name our variables and how do we name our constants. So just a good practice is to use lowercase for variables. Well, and certainly to start all variables with lowercase and don't start anything with a number. I think actually in Python, you won't be able to use a number to start it. So we have this, you can see the lowercase there. Oh, but there's an uppercase if we put two words together. So we actually refer to this, we have a special name for it, we call it camel case. And I'm sure you can get the meaning why we would call it camel case. Call it camel case because hump's in the middle, right? If we put more than one word together, we capitalize any word after the first word. right? So the second word there is capitalized, the first word is, and the rest, and everything else is lowercase. So we call that lower camel case. For our constants, we can use uppercase. Now, as I said, this would not stop the program working if you didn't do that. Program would still work. But what we try and do is have some standardization so that it's easier for you and it's easier for somebody else who comes after you to read your program and see what it's doing. So if you standardize like this, and you put all your constants as uppercase, people would look at it and say, oh, that's a constant, right? And look at the variable and say, oh, that's a variable. The other thing that would not stop the program from working, we could have just made these variables. We could have just called this S or SN, and we could have just called this one M or MS. You know, you don't have to have a big name for your variable. You could just use letters like that. You can't use numbers really, but you could just use letters. But I hope that you can see why we use the longer name. We use the longer name to give it more meaning to anybody who's reading the program, so they can read the program and say, what is that? Oh, that's student name, right? It actually means something rather than just putting S or SN. The program would work with S. It would work perfectly. But when you go to fix the program, or somebody else goes to look at the program, if all they see is an S, they might go, oh, what's that? You know? So it just makes it easier to fix the program. It's sort of internal documentation, we call that, right? It's self-documented code. The code is telling you what it's doing. All right, so Python, which is the first programming language that you're going to use, will do typing. It'll do typing by inference, and that is that you don't have to explicitly, or we call it implicit typing. That is, all you have to do is say the name of the variable and attach a value to it. And depending on the type of value that is, that will be the type of variable it is. That's not the way lots of other programming languages work. So Java, which is an older programming language than Python, and you might not use Java, but you might, but I'm not sure, but JavaScript, you may have to explicitly state what is the type of the data. So this is what we mean by types of data. Types of data, we got two different types of numbers here. We've got our integer values, which if you're in grade school talking about math, you would refer to those as your whole numbers, or you might refer to them as integers, right? So integers don't have any decimal values. Float numbers, on the other hand, do. So we could use our fractions or our decimal numbers, they would be floats. Characters, so a character is going to be an individual, and you see that like this 9 here is different than the number 9. This 9 here with the quotes around it like that, that is not the number 9. It's just, you can't do math with it. So you can't do math with characters. You can't do math with strings. So it might look like a number, but it's not. So for example, if you're going to use a telephone number, you would probably wouldn't store it as a number, as an integer. You'd store it as a string. And so there's a way of just, putting a quote on it so that the programming language knows that it's a string, not a number. Telephone numbers, student ID, you know what I mean? We don't want those to be stored as a number. We don't want people doing math on it. You know what I mean? What kind of math are you going to get out of student IDs? We can count them up, but we don't want to start multiplying them or something else. We'll get all kinds of sort of strange results. So there are some things that look like numbers, but that's not actually a number. Yeah, and we wouldn't store it. We call that a string. Displaying variables. When we'll display it with an output, as it refers to there, we use print in Python. In our flowcharts, etc., we might just say output. What's it saying here? C, A, and B are all variables. What this means is the variable C, when you see an equal sign like this is not quite like mathematics, right? I mean, it looks like simple algebra, but that's not really what it means. What this means is whatever is the value that's stored in the memory in position A, and whatever is the value that's stored in the memory in position B will be retrieved by the program. They will be added together, and the result will be stored in variable C. That's what it means. So I don't say C is equal to A plus B. What I'll say, because it doesn't mean that. It doesn't mean that in mathematics, in a mathematical way. What it means is C, the memory position C, takes the value of, that's how I say that, takes the value of A plus the value of B. C takes that value. And so that's why we're able to do things like this that I've got here, right? Count equal count plus one. What kind of math is that, right? That is not correct mathematically, is it? You know, grade 5 math, algebra, that can't be true. How can count be equal to count plus one? It's not. Not now, not ever. It's not. Count is equal to count. So this doesn't say count is equal to count. What this says is count takes the value of whatever count is before I do this, plus one. So this is a way of incrementing count, adding one to it. And so that's the way we do it in programming. So that brings us to this idea of a program state. The program state is, you know, what's happening with the program as we go. What will happen is the variables, not the constants, but the variables, their values will change. The values of the variable will change. So for example, this variable count starts out as 0. At some point, the count will get to be the value of age. Why? Because we keep adding 1 to it. Age was bigger than 0. We keep adding 1 to the age. Eventually, count will become equal to the value of age. And then this condition will be true and this loop will stop. So the state of count is changing. State of count started as 0 and eventually goes to some other value. As we go through this, the state changes every time. You can think of the state as being recorded by the value in the variable. So we use the variables to help us to understand the state of the program. Does that make sense? And the variable here is actually being used to control the program. And that's how our loop is working. Last one here, flowchart asks the user to enter the age and displays happy birthday. We're going to trace it. Okay, so how we do tracing is we use the variables to see what's happening to the variables as we work through the program, one line of code at a time. Now, I'm just going to take a couple of minutes now. We're going to do a couple of things with our Python. As I said, you guys don't have to do Python yet. You'll do it later. What I'm trying to do by doing this is let you see it enough so it becomes familiar to you. So when you do try to write Python code, it'll make more sense to you. So I'm just going to ramp up idle, which is our idle is an IDE, which is a development integrated. I stands for integrated development environment. And we're going to write the, what's this one? This is the happy birthday program, right? So I want you to see the program and how it relates to the flowchart, right? So the first thing I'm going to do is going to get the age. So I just do that like this, age equals, and age will be an integer. So I'm casting it to be an integer. I use the input command in Python, which allows me to prompt the user. And so this is the prompt. And then what the input will do is it will take an input from the user. Now notice it looks like it says equal, but again, that equal doesn't actually mean equal, does it? It means age. I'm creating the variable called age, and it's going to take the value of whatever the user inputs based on this prompt. So we're going to do that, and then we're just going to say while. So the while loop is going to, oh, I need a count, right? So I'm going to count equals 0. So this one is initialize. Initial means the start. So we're saying the starting value of the count is 0. Initialize the count to 0 while the count is less than the age. Then we're going to print happy birthday. And then we're going to add to the count. So this is saying that this is incrementing the count. Increment the count, easy peasy, just like that. There's your program. How many lines of code? I don't know, 4 or 5 lines of code. Let's try it and see if it works. Happy birthday. Yeah, I got everything there, right? I didn't miss anything. So can you see how closely this program relates to this flow chart? Right? The flow chart is actually meaningful. We can take the flow chart and represent the program. Now you might look at that and say, oh, but you got your selection in the wrong place. You got it at the end instead of the start. All right, yeah. I suppose I could put it here. It works nicely this way. All we're doing, we test it at the end. All right, so let's run it and see. You must save it. Let's save it. Let's call it happy birthday. And I probably, so just like with variables, we use camel case. With programs, we can do that too. Oops. And save it. Yes, I'll save it there. Oh, happy birthday already exists. So I don't know, somebody is age, we'll make a small age so we can count it ourselves. And it says happy birthday. Does that look like 8 times? Does look like 8 times. Now, what we could do is we can trace the program ourselves by we can print the count as we go. So I'm going to do that. So I use print statements to check the state. I'm going to check the state of the program by checking the value of the variable. So inside the loop, I'm going to check the value of the variable. So I'm going to say, all right, the count I'm going to print out the count. So I can do that by just doing like this, count. Oops. Let's run it again. So again, we're going to get a little age of 8. And okay, it's kind of dodgy. And you might have noticed that if you look at it, you'll see that, you know, wait a minute. We started out with a count of 0 and we ended up with a count of 8. Sorry, 7. We didn't get to 8. So, I mean, maybe we would change the program a bit and start with a 1 and make this a less than or equal to age. Run it again. And so our age is 8. There we go. Happy birthday, count is 1. So I do this a lot. If I was writing a program and I wasn't sure what's happening inside the loop, I'll show you how we can, on a piece of paper, we can trace it by hand. But, you know, computers do things faster than people, right? So by inserting print statements into the program, by inserting print statements in there, I can see what's happening to the program inside loops and things like that by just printing out the values of all the variables. I can see, so if I made a mistake in the program, you see that I actually did tweak the program just now, didn't I? I tweaked the program because I didn't like it starting with a 0. It looked bad. All right, and so I can see what's happening, and so that will help me to fix my program. Now this, you know, this is information that the person doesn't need. Did I actually put the value of 6? Yes, I did. This is it. So when you are done, you might remove that print statement. Now I might leave it there so that I can use it again by putting the hash in front of it. That makes it into a comment, and comments aren't used by the program. So it just like that. So that's kind of how we would do that. So there is a flow chart. That's the flow chart has been put into a program. Let's try the other one here, which is I will not cheat. Oh, right. Yeah. All right. So this, the one behind us, this is a counted loop. Counted loop, what it looks like in a flow chart. Counted loop, what it looks like in a Python program. Let's do another one here, which is the counted loop as a Sentinel. So this is the not cheat. And so when I put a hash like this, you see that the color went red. That means that that is a comment. It is not processed by the interpreter. Remember, Python uses an interpreter, doesn't use a compiler. Interpreter means that it translates the program one line of code at a time. When it sees this, it just ignores it, right? The interpreter says, oh, red stuff, hash stuff, forget it, forget about it, right? So what we're going to do is we're just going to print I will not cheat. So we need to have a Sentinel value for that, right? So, okay. So are we going to print it once? Or do we want to have a choice to not ever print it again? Sorry? Always print it once? Choice before we start. Okay. So I might just say, I can't think of what else to say. So I'm just going to say not cheat. Notice when I just did the not, it came out as orange. When you see orange things like that, that means it's a what we call a reserved word. It actually means something in Python. So this means it's going to reverse the meaning of some other Boolean value. So I'm going to not cheat. I'll just call it cheat. Well, that's a nasty word, isn't it? I don't like that word, but what can we do, right? So we're going to say cheat is equal to y. So this could be a Sentinel value. Yeah, so cheat equals y. While cheat I used the word equal, but I didn't put it in there. And it doesn't mean equal, it looks like equal, but what this means is cheat takes the value of y, right? So a variable called cheat is going to be set up in the memory, and we're going to store in that memory position the capital letter y. So while cheat is no, I could write while true, but I can't write while y. I have to say well, because y is just a value which is being stored in the variable cheat. So yeah, I could say while true. Maybe we'll look at that in a minute. Let's try this. While cheat is now when we do equals for equality testing. See, I told you that the equal sign doesn't actually mean equal. This is the thing that actually means equal. What we're saying is this thing equal to something? So while cheat is equal to y, I might do this, or cheat is equal to little y, because the person might put in a little y or a big y. And so there, what you're seeing there, what we've got is a compound condition. We've talked about those before too, right? Compound condition, a condition where we've got two conditions together. And what this is saying is if either of these is true, then this while condition will be true. So while it's those things are true, we're gonna print so actually I'll just say input. Finish. Now, the way this is working is it wouldn't matter what they type as long as they didn't type a big Y or a little y. If they type big Y or little y, they're going to end. They're going to continue. Otherwise, they won't. So I'm hoping that will work. I haven't tested this, but yeah, I think so. So this is a Sentinel loop. What we're asking them, it should be again, right? It should be again or and. Oh, all right. Sorry, I should have done that. So this should actually say again, if it's going to be the same as that thing. Again. I could do, let's forget that. let's make it that they have to say again. And so continue, type again. Anything else they type will not work. And so this is actually gonna, this is actually, so I try to make it like the flow chart. All right, so let's see. Okay, so cheat. I will not cheat. Continue, say again. I will not cheat. Now, if I type anything else, still going. What happened? Can you see what happened? I didn't set it equal to the variable. I did the input, but I didn't put it in the variable. Says, good thing we're testing it, right? So let's try again. How did I do that? All right, so I will not cheat. Type again. So as long as I type again, it should say I will not cheat. But if I type anything else, it ends because it's not again. I could have put a else, you know, if I, but anyways. So this is the flow chart, and beside it is the program. Anyways, I hope that makes sense. Good. I think I'm going to stop there. What I'll do is we'll take a break. I'll go upstairs. I'll get your flow charts from the previous test. You can look at them. I'm going to ask you to give them back to me because I'm supposed to keep a record of them, but I'm also supposed to let you see them. I think you've all seen your marks because I put it onto D2L. I haven't put it onto PeopleSoft, but you'd be able to see your mark on D2L. And then I'm going to stop this share.